to my video where I made a project called AI powered vulnerability scanner built entirely using Python, Zap, and machine learning. So, if you're into cybersecurity, ethical hacking, or just Python in general, this is a great project. I've combined the power of OWASP Zap for scanning web application and integrated AI models to predict the severity of the vulnerabilities and suggest solution based on the past data. So what my code basically does is, so as you can see we have five modules. The main modules: app scanner, text utilities, and a report generator, and AI model. So a little backstory why I thought this was necessary is because OWASP Wrap has a very scary looking GUI that many technical users cannot use. However, it's a great pen testing tool that helps you identify vulnerabilities in your website. The problem being that this report is not exactly readable and many people don't know what to do and how to fix these vulnerabilities they get. So I have created a program that gives you remediation techniques as an HTML form. Um, so let's look at our code. We start, so this is the driver code that is basically using all of these modules I made. We start off with Zap Scanner, which is the Zap scanner, which is the configuration of the scanner itself. It has these three it has these two types of scans: firing, where it goes through every enumerates through every subcategories of the domain, and then the active scan itself. Then we have the text utils, which is implementing my LLM. The reason I use LLM is to create a very friendly version, like a non-jargon friendly version for people who are not very familiar with cybersecurity terms or terms like SQL injection. A basic explanation on what it means. I have made a little dictionary array, a replacement that if my report or if the output generated by OWASP says SQL injection, it's a database manipulation. If it says cross-site encryption, it's a website code injection, and so on. Then I have the AI module, which is the core logic, which implements SVM and ANN through for database learning. It helps it basically trains an SVM to predict CWE IDs and uses ANN to predict severity of a score. It is very zero days vulnerability friendly tool. It can identify, like based on predictions, it can identify 0 days vulnerabilities, and it basically what it does is it trains the data model first, reads the Excel file. It's a placeholder, so don't worry about it. It reads the database file, and then it like step by step by splitting the XLS database. This is my database, by the way. So I made this by by identifying the Zap alert names, what it is targeting, what is being targeted in by those attacks, the injection method, the payload, what the malware coding is like, the CWEs, the CVE is mapping to those CWEs, the risk that I found through NVD, which is a very popular framework in the cybersecurity field. It's like a scoring vulnerability scoring system, and it helps my ANN model to prioritize how severe the vulnerability is. Then it's a remediation tactic, how to get rid of this vulnerability identified by OWASP, and here is the description of what the vulnerability is doing. So based on this database, I've trained my model. It splits all of the columns, and then it reads all of the columns, and it makes an array based on all of the columns for as a cache. Then we train our array based on the CWE, our SVM. Sorry, I'm so sorry. We train our SVM model based on what it gets, like of what it learned, and we train our ANN model based on the risk score tools and the CWEs. I have also taken into account in case of any characters or encoding scheme, since it contains payload that can generate an error. However, I've taken it into account. Like I've provided a very well error-free environment in case there is an unidentified character. Then there is our predict function where we are predicting what risk or uh, in case of a new output we are producing what kind of risk it is. We're creating a risk map on how severe the risk is. Is it informational, low, medium, and then based on this we're categorizing the risk based on our ANN model is helping us categorize the risk, and our SCM model is predicting the CWE, and through this CWE ID it's providing all of the description what the vulnerability is about. Lastly, we have the main file that brings it all together. This is GUI Tinker, a very minimal native Python GUI, and it basically starts the scan, runs the scan, all of the WhatsApp configuration. So when you run the configuration it takes a while, that's why it takes a while, and it basically runs all of the scan at the back end. It's showing you all of it's happening all at the back end, and then it produces a result in the form of an HTML report where if you press the button you get the um, little you get that it is what the code is, or what the vulnerability is um, um, with a whole severity score and all of this vulnerability. I checked an intentionally vulnerable website called test.php that has a timestamp total number of vulnerabilities found, and the GUI is very minimal. You get this warning because of TensorFlow. So if you want to get rid of the warning, you add a little code at the top, please. However, I've I haven't saved the code. I see it takes a lot of. So as you can see, this is the GUI, very minimal, and to generate the report, and it works at the back end. So I've already generated a report for this. I went to the point. As you can see, again generated it, and it works. I'll do it again. You get the scan thing, and then it starts all over again. Since it's already been done, I'm not gonna wait for it. So then it produces this output, and yeah, that's it. Thank you for watching my video.